This is the first video in your makeup assignment for February 13th. This video will help you answer the first question on the Google form in your email. This lecture starts us with our information on linear systems, and we are starting with a linear system in two variables, which you see right here. And this can be found in 9.1 in your book, and it corresponds to the homework in 9.1. A linear system is defined as follows. It is an equation. It's a system with at least two lines. It can have more than that. But this system we see here, notice both lines are in standard form, and the x and the y are our variables. And the A, B, C, D, E, and F are going to be numbers. A, B, D, and E are called coefficients of the variables. And C and F are called constants, since they aren't associated with a variable. When we work with linear systems, usually we try to find a solution, and the solution is an ordered pair or a coordinate x and a coordinate y that is true for both equations. Okay, so we don't just want a point that works for one of them, we want a point that works for both for it to be a solution. Now, if we think about graphing two lines, that gives us three possibilities that we see are listed here below. The first possibility is that the lines intersect at one point. And you'll have to ignore the kid toy that just went off. Hold on just a minute. So in this case, the two lines intersect at one point. So notice, since they intersect, they only share one possible solution. So this has one solution. And this is what it would look like graphically when the two lines intersect. Now the second solution would be if we have parallel lines. And notice when we have parallel lines, we already know that these don't intersect at all. So there's going to be no solution, because there's no points that they share. And the third possibility is that if we graphed two lines and they actually graph the exact same line, it's just right on top of the other one. And since these are identical lines, there's an infinite amount of solutions because all of the points intersect and they're all the same. Now you'll also notice by these three possibilities that we have the terms consistent and inconsistent, or independent and dependent. And I'm going to define those for you on the next slide, but just know that consistent means there's a solution. So notice possibility number 1 and possibility number 3 are consistent because they actually have a solution. 2 is inconsistent because there's no solution. And independent means you can see the two separate lines. So notice in these first two that we can see the two separate lines. So they're totally independent of each other. Whereas the third one is said to be dependent because they're right on top of each other. They're kind of multiples of each other. So they're said to be dependent on each other. So let me show you the definitions for those. So consistent and inconsistent deals with if there's a solution or not. So solution, question mark. If there is a solution, it's consistent. If there's not a solution, it's inconsistent. And dependent and independent basically means, are they separate or not? So separate, question mark. Are they two separate lines? And if that's yes, they're independent. And if they're not two separate lines, then they're dependent. because they're basically multiples of each other. We're going to learn how to solve systems today algebraically. And we're going to learn two methods, and that's going to be in video 2 for the substitution method, and we're going to learn the elimination method, which will be in video 3. And then we're going to look at an application quickly in video 4. So you can go ahead and answer the first question in your Google form and then watch the next video. Thanks.